We're live. We left off yesterday, and I was talking about how this 6 theta should have been 6 theta plus 360n, and I also said that sometimes I put that 360n over here with a 90. It doesn't matter in our equation if it's 6 theta plus 360n equals 90, or I could have solved it a different way. It could have been looking like this. It could have had 6 theta is equal to 90 plus 360n. Both of these will give the same answer. So it doesn't matter where those 360n lives. You just need to make sure that you have it in your initial equation. And I think I said this yesterday too, but this one makes a little bit more sense because when you divide both sides by 6, then you're done. You don't have to like move around the 360 degrees end. I don't know why I randomly put unit there, but not anywhere else. I'll just erase that. Okay, so we know what our modulus was. We took both of these powers to the 1/6 power, and we said 64 to the power of 1/6 is 2, which means the answer that we're looking for has a distance of 2 from the origin. Our modulus is 2. Now we're asking, okay, well, what is the angle that we're looking for? And again, there are multiple answers. The way that we solve that, I'm going to use this equation because it's easier. I'm going to divide both sides by 6. So dividing both sides by 6, I have theta then is equal to, okay, I have to do a little bit of math now, 90 divided by 6. 90 divided by 6. I can divide the top and bottom by, I don't know, 2. That's nice and easy, right? If I divide that by 2, I get 45 over 3. Ooh, 45 is divisible by 3. What's 45 divided by 3? Say it louder. 15, yeah. 15. So I'm going to have 15 plus, okay, I also have to divide 360n by 6 because I divided everything by 6. All 3 of these terms are being divided by 6, so more scratch work. 360n over 6. I know my 3 can look a little bit better. I'm going to blame the whiteboard wiggling back and forth. What's 360n divided by 6? Someone aside from Beverly with a quiet raised hand. 360n divided by 6. Chewy, help me out. What's 36 divided by 6? 60n. You already got it. There it is. So I can say plus 60n. And this is the answer. That is your theta. You can choose any integer or any whole number. That's the same word, right? Integer, whole number. Any whole number for n. If I choose 0, 0 is a whole number. So if I plug in, again, I don't know, I'm running out of room here. Let me erase over here to give me some room. And I'll make my arrow point all the way over here. My value of n can be anything that I want that's a whole number. So the way that we say that formally is n is a subset of an integer. It's not super important that you know this, but the main thing that you need to know is that these are the possible values that you can have for n. I can have -1, 0, 1, 2, -10, 1,000. Any whole number will work for n. You get to choose whatever you want. On Khan Academy, there's only going to be one value of n that works. On Khan Academy, we'll say, make sure that your angle is between, what do they say, like between 60 and 90 or something like that. So let's go ahead and make our problem kind of like Khan Academy. We can say, okay, how do we restrict our theta so that we're between 60 and 90? So the question is n is equal to, oh, that's the sub question. I'll just say up here, this was the original problem. We'll make the problem extra hard by saying theta needs to be between 60 and 90 degrees. Oh, does it already say? Oh, even better. Okay. It already is hard. I should have it in front of me. 180 and 270. Perfect. 180 and 270. Okay, so let's try plugging in some values. And we're on 1-12 notes. We're on the very back still. What's up? All right, so let's try plugging in 0. If I plug in 0, I get 15. 15 is not in between 180 and 270. So one of our answers And I can maybe make a table here. I'm running out of room here. Problem with the small whiteboard. If I make a table of n values, what is my theta? If I choose n to be 0, and then I plug in 0 here, it's going to be 15. If I plug in 1, it's 1 times 60, which is 60. 60 plus 15 is 75 degrees. I can't write. 75 degrees. Again, we're getting closer. Again, we're trying to shoot for this range between 180 and 270 degrees. Let's try 2. If I plug in 2, 2 times 60 is 120. 120 plus 15 is 135. Again, we're getting closer. It's probably the next one that's going to work. If I plug in 3, 3 times 60 is 180, and 180 plus 15 is 195. Do I have any what? I can put them out to the office. Here, let me put them out to the office real quick. I'll pause the recording. All right, so we have our theta. Our theta is 195 degrees. I wonder if another one would work. Let's keep going. I want to see what happens when n is 4. When n is 4, 4 times 60 is 6 times 4 is 24. So it'd be 240, and then another 15 would be 255. Yeah, and this is a case where 2 answers work.
Wait, so is the goal of these problems to find n?
It's to find a solution. Find one complex number such that that complex number raised to the power of 6 is 64i.
And is that
N is just a
n is something else?
n is just how many times I can rotate. N is the number of times I've rotated around to get to any one point. Have I rotated 1 times 360? Have I done 2 times 360? It can be any time, any number of times I want.
Okay,
In order
we
to
just have to figure out one of the ranges and then we add it and then.
So yes, I mean the value of n will help us find certain values of theta. So there are 2 values of theta that work. Again, remember that a complex number, which is the thing we're trying to find, z, a complex number is really just, come on, Oscar, is just an angle and then some distance along that angle. Let me come back to some basics here. Where I put my eraser? Back here. What I'm trying to find right now, is some point on this complex plane. Once I find that point, I'm done. How do I find that point? I'm trying to find it so by finding some angle. Maybe I say my angle is right about there. This angle, and then how far along that angle do I move? And then I get to a point. I've shown you guys on this side of the whiteboard that I can move. My starting angle could be either 195 or 255. Both of those will be solutions. And then how far do I move at that angle? I move a distance of 2, a modulus of 2. I realize I don't really need to wear my mask, do I? Those are my answers. And then those 2 points that I've drawn on my complex plane, when I take those points to the power of 6, it will end up at 64i. We're still not done though. We don't know what those points are. We can represent them in polar form or in rectangular form. I want to show you both. So I need to remember these numbers: 2, 185, and 255. So from the previous side of the board, we know that R, my pen is failing, R is equal to 2, and my 2 different thetas, I'll call it theta 1 and theta 2, was 195 and 255. I wrote those down right? 255. Add what?
Or you already added.
Yeah, those are the exact angles with the 15 and the 60 all multiplied and added. Okay, so there's a formula that I told you guys to write down yesterday, which was this. It should be under the trig section for special right triangles. A is equal to your absolute value of z times cosine of theta. And then B is equal to your modulus, your absolute value of z, times sine of theta. You're going to need both of these formulas for this problem because these are not nice triangles. They're not 30, 60, 90. They're not 45, 45, 90. You're going to have to use a calculator to find the answer. So how do we do that? Well, z is another way of saying r. So I can say that r is really the absolute value of z. They're representing the modulus. The modulus, or the distance here, is 2. So there's 2 answers. Here's the first one. And I'm going to need some calculators ready to go. So do you guys have your laptops ready? Can you guys open up desmos.com/scientific, the calculator one? What's up? We're almost done with this problem. Like, we've spent so long on it, I really want to see the conclusion. Can you open up to Desmos, guys? Because you're going to be doing this on the homework tomorrow and tonight as well. So. Okay, in polar form, I'm done. In polar form, here are the 2 answers. 2e to the 195i. That's one of the answers. The other answer is 2e to the 225i. Both of these are answers such that if I take them to the power of 6, this ends up at 64i, which is nice, but you don't know where 2e to the 195i lives. It's really hard to picture what quadrant am I even in. And maybe you're smart, you'll be like, oh, 195, that's in quadrant 3. I want to show you guys using rectangular form instead of this Euler's polar form, how to visualize these numbers. And it's using these formulas. So on our calculator, the first number, I'm just going to deal with this theta 1 number, this theta 1 angle, I should say. It's going to be 2 cosine of 195. That's the real part. So type this in your calculator. We'll convert that. And that's going to be plus 2 sine of 195. That'll be our I. So can someone do 2 times cosine of 195? Give me, I don't know, 2 decimal places. You're gonna have to say it a little bit louder with the mask on. 1.93. Okay, and then someone else do 2 sine of 195. Just one, 0.52i. Okay, there it is. This is one of the 2 answers. Just like this is one of the 2 answers. These 2 are the same number. This one is in polar form. This one is in rectangular form. Okay, then I'm going to convert the next one. I'm going to convert this one with 225 degrees. It's the same formula. It's going to be 2 cosine, but instead of 195, it's going to be 225. So over here, I'm going to write 2 cosine of 225 plus 2 sine of 225. And that one has an I on it, right? So I can put the I in front or behind, it doesn't really matter. Somewhere that second part has to be the imaginary part. All right, calculators. Someone aside from Beverly, someone aside from Ellery. What is 2 cosine of 225? Yeah, Leo. Can you say it louder? One more time, negative 1.41. Okay, thank you. And someone else that's new. 2 sine of 225. Same. So negative 1.41 minus 1.41 I. And 1.41 is that the square root of 3? What is 1.41? Can someone do the square root of 3? What is the square root of 3? Okay, yeah. What's the square root of 2? Because it's a 45, 45, 90, so that should actually be a square root of 2. So that is the square root of 2 then, isn't it? So this one you could have used a special right triangle to solve. So another way of writing this one is negative root 2 minus root 2i. So I'll box both of those. So everything up here is an answer. They're just in different forms and different locations. So I want to draw out where 225 degrees is to show you the special right triangle. So 225 degrees, so 270 is straight down, and then I have to go backwards 45. 70, yeah, that's right. So
What would you put on Or are we still like?
I'm showing you a different method, but on Khan Academy, there'll usually be just one of these and not the other. So you'll probably write this one, -2 or negative root 2 minus root 2i. So this would be your answer in Khan. Like if there's one answer, I would start this one. And you can find that this is square root of 2 by this process that I'm about to do. If you draw out 225 degrees, again, I'm just drawing this polar coordinate, 225 degrees, I have a modulus of 2. This distance along the diagonal is 2. I'll go ahead and drop a line to the real axis. How do I move from 2, this hypotenuse of this 45, 45, 90 triangle, to the leg? What operation do I do? Ellery. Divide, yeah. So the general idea here is if I'm getting something smaller, I'll divide. If I'm getting to something bigger, I'm going to multiply. The hypotenuse is bigger, so I'm going to something smaller. Yeah, so divide by the square root of 2. And then how do I do that? 2 divided by the square root of 2. I have to multiply the numerator and denominator by root 2 over root 2. So root 2. That's going to give me 2 root 2 in the numerator. The denominator is going to be square root of 4, and I'll do really intermediate steps here. Root 4 is the same thing as 2, so maybe I can just come out here and say this is going to be 2 root 2 over 2, and then the 2 in the numerator and denominator cancel out, and this is just going to be square root of 2, which means the distance here of the leg is the square root of 2. Square root of 2, square root of 2, and I went left, so it should be a negative, and I went down, that should be a negative. It's -2 or negative root 2 minus root 2i, which is this answer down here. Whew. These problems are long and tedious. All right, now this is the part where I'm very nervous. We've had this whole lesson go over 3 days. Let's just talk about this last part. Fist of 5 on how well you could do something with square roots and stuff in it. A 0, a 3, a 0, a 0, a 2, a 1, a 2.5, and a 2. That's about what I expected. Now's a good time to go to the bathroom, yeah. All right, and that's all we have for the lesson.